call this pattern keep, change, change. And the reason why I like keep, change, change is because all of these versions where we add things, where we're adding the equations, they make so much more sense to me than the versions way back up here where we are subtracting things that don't exist or that we can't see like that. It makes way more sense to me to turn, because we've already talked about how these are the same, how we've already talked about how 4 minus negative 3 is going up, and the other thing that is also going up is 4. The other thing that would have the same result is 4 plus positive 3. That is also going to equal plus 7. And so the only difference between these is that we left the sign of the first number the same. We changed the next sign. We changed the operation from negative to from subtraction to adding, and then we changed the sign of the negative 3 to positive 3, and we still get the same thing. So if we can always do that, then we can do something called keep, change, change. That will become a little bit less confusing. So keep, change, change is just a pattern where when you see a subtraction problem or you see a problem that you don't feel comfortable with, whichever one it is, some people don't like the idea of adding negatives. They like the idea of subtracting positives more. So whichever one you see, you can change it a little bit. So keep, change, change works like this. Keep, sorry, I wanted to look at something. Keep, change, change. What you keep in a problem, let's say we have the problem negative 5 minus negative 3. Actually, you know what? Let's make it positive 5. Positive 5 minus negative 3. What we're going to keep is we keep the first sign. So we keep sign of first number. We don't change that at all. That stays the same. But then what we do is we change the operation, and then we change the sign of the opposite, or of the change sign of second number. So when I do keep, change, change, this is going to turn into, let's see, if I keep the positive 5, I change the subtract to add, and I change the negative 3 to positive 3. So let's see, we changed this to that, and we changed this to that. Keep, change, change. And 5 plus 3, a lot of students, a lot of 7th graders get confused by 5 minus negative 3, but understanding that it's the same as 5 plus positive 3, 7th graders can all do 5 plus positive 3. You can literally count that on your fingers. So that's how keep, change, change works. And you can use it for any set of numbers. You can change things back. Let's say I have 5 plus negative 3. Well, some people don't like the idea of adding negatives, but let's see what happens if I do keep, change, change. I keep the 5 positive. I change the addition to a subtraction, and then I change the negative 3 to positive 3, and now it's just 5 minus 3. Everybody knows that is 2. So this is sort of another thing that's nice to know, and I think it sort of ties in with the zero pairs and the absolute values. But we can always use keep, change, change to help us solve problems. Keep, change, change does not work in multiplication. It only works in adding and subtracting. But it is a good pattern, and what I like to do is I like to just go through and change all of my subtraction problems to addition. And then I like to follow the zero pairs rules once I have it as addition. I just think that works really well. Just think about the balloon and the stick. So that's it. I think this is all we're going to do for integers.